I gotcha. Okay, everybody should be on this page right here. If you're not on this page, make sure you flip to it. We'll give you guys 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so everybody should be on this page right here. Again, I know some of you have already done this and some of you have started it. I just want to go through the math pages really quickly, talk about what we're supposed to be doing so you guys can make sure you get it the right way. Then we'll break for just a little bit and have you guys work independently, and we'll come back like we always do, and we will go through everything together. Okay? So, that should also give you guys some time to catch up on any other work or just study for spelling, that thing in between. But I do think this is going to be pretty easy, but I did want to make sure that we had enough practice with this and enough review that you guys feel really comfortable with it, okay? For what I was noticing yesterday, it actually seems more like we probably need to do more equivalent fractions. Seems like the comparing is a little easier. Question. Is there, I'm sorry, I can't hear what you said. Again, can you do that question? Okay, good job. Good question.
I'm already done with the math and I already finished one of the
Okay, good. Okay, guys. So, let's talk about these really quickly. This one says, identify and compare the fractions on the number line. Okay? So, if all you did was compare the fractions, but you didn't mark them on the number line, make sure you go back and you mark them on the number line. Because that's what identify means. You want to turn that in? Go ahead, in the middle basket. And then Andrew, make sure you flip to this page. So, if you did not mark them on the number line, but you identified, but you compared them, make sure you go back and identify them, mark them on the number line. Where would I put a dot for 1/2 on the first number line? Schmidt. That's right, right here. That'd be 1/2. Because remember, a number line, 0 to 1, we're talking about that's one whole, right? Each one of those lengths, or segments, or jumps, what we're counting, okay? Where would I put the 1/4 on the bottom number line? Brewer. You're saying right here? That would be 2/4. That's 1/2. You mean the first one right here? Oh, I see what you mean. So you're calling that the second one. Remember, that's 0, that's 1, so this is the first one. Right? I see what you mean. Right there. So now that they're marked, which one is greater? Which one's greater, Andrew? That's right. 1/2 is greater. You can tell it's further along, right? 1/2 is closer to 1/2 than 1/4 is, correct? Okay? So that's what you're doing on these. But if you do not have those marks, and I'm coming around, I'm going to tell you guys you need to come back and mark them. So for those of you who said you already did it, if you don't have those identified, you didn't mark them, you need to do it. That's part of it. Now on the second page here, this is pretty much just like what we were doing, right? The only difference is, again, are these denominators the same? Are they the same? No. Who wants to tell me what the denominator means again? What does it stand for? What does it stand for, Deva? It's all the parts in the whole, right? Exactly. So that's why we've got 2 different bars, because this one's divided into 3. 1, 2, 3, so it means it goes in that one. And this one's divided into 2, which means it goes with that one, right? So again, don't let the numbers fool you on these, okay? Look at the pictures. Which one has more shading? Heston? Which one? This one right here? So is 1/2 greater? Yes, it is. That's right. 1/2 is greater than 1/3. And again, like I said, if I use my Kit Kat analogy here, I would say if I cut a Kit Kat into 3 pieces and only give you 1, and I cut another Kit Kat into 2 pieces and gave you 1, which one would be bigger? That's right, the 1/2. It's a better deal. It's a better deal. Okay, so you're doing the same thing on those. And then this one, you got a couple different things you have to do on it. It says shade and compare. So on this one, you're not just comparing, you're shading them as well. Okay? So if you compared and you didn't shade, then make sure you went back that you go back and you shade. This one here, how many of these do I have to shade on the top one? How many do I need to shade there, Nick?
2.
That's right. For 2/5. 2 out of 5. For 2/3, how many do I need to shade? What do I need to shade there, Jed? That's right. Now, Ariana, which one's greater? 2/3 or 2/5? 2/3, exactly. So again, don't let the denominator fool you. Because remember, the more pieces that it's cut into, the smaller those pieces are. Now, if it had said 4/5, then that one would have been greater, and you would have been able to see it, right? So if ever you have a number like this and you need to draw out a fraction bar or model, do it. Draw it out. Make your lives easier. The other way to remember this is with the number lines. I know you guys don't like number lines very much, some of you. But the reason why the number lines are nice is because really what you're looking at is both of them are from 0 to 1 whole, and you're just looking at which number is closer to 1 whole. So you're kind of thinking about it in terms of length or distance, right? And if that helps you, draw out a number line. Use what helps you, okay? Thumbs up? You guys get it? Okay, so let's go ahead and work on this for a little bit. I don't think it's going to take you guys very long. I'm going to come back to you at about 9 and see where everybody is, and then we'll go through them all together. I think that gives everybody probably plenty of time to do it. If you need a little more time, we'll do that as well. Okay? Any questions before we start? Heston? Okay. I'll come over there. Okay, so everybody should be back on this page right here. And remember, our goal here with doing this is because all of you are done with it. I want to, 1, make sure that we're all on the same page, figuratively, so we all have the same understanding of how to do this. And I want to be able to have you guys share your answers with me and the class. Okay? That's why we go through it. We make sure that everybody's got everything. It's a chance to check your work as well. Okay? Remember, of course, and I don't think this is an issue today because I'm fairly certain everybody finished it, and I think, for the most part, that you all got everything correct as well. But it is never time just to copy down answers, okay? It is a time, though, to give you some examples to make sure that you're understanding. Okay, make sense? Thumbs up? Good. Okay. So, everybody's on this page? Yes? Everybody? Everybody? Yeah. Bueller? I don't think I'm going to get that.
Did you just say Bueller?
I said Bueller. Oh, Seller's got it. Seller's got it. Somebody's been watching 80s movies.
It took me a minute to have that click.
Bueller. Okay. Here we go. Let's go over it. So we did the first one together. We already did that one. Let's take a look at the second one here. Remember again, and if it helps you to keep marking them, the lines are always 0 to 1, right? 0 to 1. Because that's our whole length. So on this very first line, Talon, where do I put 3/4?
The fourth line.
So 1, 2, 3, you mean 1, 2, 3, 4 right here?
Yes.
So you're counting over from the 0. I got you. 3/4 would be right here. Now, the next one is divided into 6ths, right? We know that not only because we can see it, but also because the denominator is 6. We know there's 6 lengths, 6 parts, 6 jumps. The galley was the one who called them jumps when we were jumping, right? Brewer, where do I put 3/6? 3 parts out of 6. So 1, 2, 3 like this, or 1, 2, 3 like this, you mean? Yes? Which is now Looks to me like that's right in the middle. What is 3/6 equivalent to, Allie?
3/6 to half.
That's correct. 3/6 also equals 1/2. See how it's right in the middle?
I almost forgot.
No, you got it though, because remember, guys, what's half of 6?
3.
Exactly. So if you see 3/6, you know it's 1/2. It's 3 parts out of 6, right? Now, which one's greater than? Which one is closer to the 1? Which one's closer to the 1, Briggs? 3/4. That's right. Everybody got that one? I want to make sure we all got the same thing here. Good. Okay, now, what about on this last one here? We have, again, remember that first dash you can see there. The first mark is always 0, last one's always 1. That's our whole area, right? So, Tava, where do I put 2/4? On the 4th line? You mean right here?
Yeah.
Are you sure about that? It's 2 parts out of 4. So if you have 0 here, 0, 1, 2. What do you think? Where the 1 is? You sure about that? That's 1 whole. That's 4/4, right? And that's 0. This is 0/4. So if I was counting this direction, right here, you got it. 2/4. Exactly. That's right. So when in doubt, you can count, right? And you can count the jumps, not just the lines, but the jumps. Remember, 1, 2. That wasn't a perfect draw. Guys, what's 2/4 equivalent to? Ariana? 1/2. Because what's half of 4? Wait, say that again?
2.
So you can see that 2/4 equals 1/2, right? Okay, now 2/5. No, that means the next one is divided into 5 parts. 2/5. Abigail, where do I put the 2/5? 1, 2, like this. Oops, I moved it. Like that? Right here, exactly. Because remember, if you have to mark them all, you can. This is 0/5, 1/5, 2/5, 3/5, 4/5, and 5/5 is the entire whole. That's 5 parts out of 5, right? Okay, now, looking at this. Now that we have them marked, which one is the greater fraction? Which one is the greater fraction? Wilkins. 2/4 is the greater fraction. That's right. So you can see it visually, but you can also see it because 2/5 is 1/2. 2/5 is 1/2, so it means you're getting half of whatever it is, or you're halfway there if you're looking at it as distance, right? You're halfway there. Whereas 2/5 is obviously less than that, 2 parts out of 5, right? Okay, so let's take a look at the next one here. We did the top one.
Everybody should be flipping their page.
Everybody should be on this page now. Next page, let's go. Ian, flip your paper. Allie, flip your paper. On to this one now, guys. Schmidt,
I have one thing.
you have one thing.
And it's about the math.
And it's about the math. Good. Should be.
Okay. Can we start out which one's greater, but when we're like picking, can we start out which one's greater?
We probably can do it that way. But I do like to make sure that I'm getting everybody participating. And sometimes people are choosing not to. I'm probably just going to start picking people as well. But what I do want you guys to call out, I will do this. Now, of course, if I'm talking to an individual person, I've already used their name when I do that. It just means I can't hear you. So, you have to use context clues to tell. Okay? But what about this one here, Talon? Which one's greater? 3/4 or 3/8?
3/4.
That's right. You can tell, right, guys? Because look how many of these are shaded in. And look where it lines up. Look how short this one is. If you're looking at it as a number line, pretend these are number lines. 0 to 1, 0 to 1. You can tell that this one is closer to 1, right? It's whichever one is closer to the whole. Now, for the next one, we're on some circles. Okay, guys, which one's greater here, 2 6 or 2 4ths?
2 6.
Oh, I heard somebody say 2 6.
2 4.
It's 2 4ths, guys. Look at it. Because 2 4ths is equivalent to what?
1/2.
That's right. Check it out. Same thing. If you cut it right in half, it would be 1/2. 2 4ths is equivalent to 1/2. This one, though, it's not. You can tell it's the missing part. Do not let the denominators fool you. Make sure that you're looking at the shading as well. Trust your eyes on these. Okay. What about 3 6 and 3 4ths? Which one's greater?
3 4.
That's right. Again, you can see it. 1 2 3. Takes up more space. It's a better deal. It's a better deal. Because in this case, 3 6 is equivalent to what?
1/2.
That's right. This is half of the pizza. That's way more than half the pizza. Right? That's a better deal. That's the better deal. Okay, now on the number line, on this one, we have the same denominator, correct? Yes? What's our denominator?
3.
And what does that mean? What does it mean? Brewer, what's the denominator mean?
That is 3.
There are 3 what?
Holes.
No, there's only one whole. One whole, but it's divided into how many parts? That's right. 1, 2, 3. Sorry, hashtag sorry, not sorry. 1, 2, 3 jumps, right? We have 3 lengths that this is divided into. That's what that 3 stands for. Now the numerator. What does the numerator stand for then? What does the numerator mean? Schmidt.
How much is
Or which one we're marking, right? You're right. It's the one that's represented, right? So in this case, where does the 1/3 go, Jed?
At the first blank.
Right here?
Yeah.
You're right. 1/3, right there. Now where does the 2/3 go? Where does the 2/3 go? Wilkins?
On the second one.
Right here. Sellers, 1 whole then in this case is equivalent to what fraction? How would you say it as a fraction? If we have 1/3, 2/3, what's the next one? 3/3. That's right. Because it's 3 parts out of 3, so it'll be 1 whole, right? Okay, now, which one of these fractions is greater? Which one of the fractions is greater?
2/3.
That's right. 2/3. It's closer to 3/3, right? Okay. You guys are getting these. Now let's take a listen. We did the top one here. Now let's take a look at this one. We have 3 4ths and 4ths. Now, of course, these are easier, right? Because the denominator is the same. Which means that we have 1, 2, 3, 4, 1, 2, 3, 4 parts in each one of our holes, right? 4 parts in each one of the holes. Everybody should be on this page right here. If you are not, make sure you flip there. Now, Andrew, how many parts should I shade in for the top bar? 3 of them. You're right. Now, does it matter if I do something like this? Still means the same thing, right? Now, how many parts do I shade in for the second one? For the second one. Who's going to talk to him a little bit? Tava?
2.
2 of them. And it doesn't matter if I do it like this, does it?
No.
Now, it might make it look a little more confusing, but now you're just looking for quantity. How many of them there are, right? So in that case, Talon, which one's greater?
3/4.
That's right. That's right. He's got it because 2/4 is equivalent to what? That's right. Even if it doesn't look like we've taken half, we have. We've taken 2 out of 4. Right? That's 1/2. Exactly. So what about this one here? We have 2 different denominators, which means one is cut into 5 parts, one is cut into 4. So on the first circle, Schmidt, what should I be coloring in here?
1.
Just one of them. That's right. Now on the second one, what should I be coloring in, Talon?
1.
That's right. Nick, which one's greater?
1/4.
That's right. Now, when you look at the picture here, it's close, right? Really close. But 1/4 is greater. Jen.
The next greatest one is 3/3 because it's the whole.
That's right. So how many of you guys noticed that? I hope everybody noticed that. Thumbs up if you noticed. I know Nick noticed because we talked about it. Yeah, everybody saw that one? So 3/3 is greater. Now, that means on the first one, Heston, how many should I be coloring in on the first one?
2.
That's right. 2 of them. And then on the second one, Sellers, how many should I be coloring in? All 3? Whole thing? Just like that? That's right. Exactly. Because 3/3 is equivalent to what?
1/4.
Who said half? Guys, do not just repeat what you hear other people saying. It might not be right. I need you to know your answer. What is 3/3 equivalent to?
1/4.
Clearly, we colored in the whole thing. 3 parts out of 3. If I said, hey guys, I've got 3 cupcakes, I'm going to give you 3 out of 3. I would be giving you all of them. That would be the entire amount of cupcakes that I have, right? Alex.
You're making me hungry by using food as an example.
Yeah, but what's more fun than food examples? I don't know what else I would use.
Animals.
Use what?
Animals.
Animals? So if I said to you, what do you mean? Like cutting an animal up? So if I said to you, I have 1 snake cut into 4 parts. That doesn't sound very good. Fine. I could say I've got a tank full of 4 snakes. And I'm going to give you all 4 of them. That would be the whole, right? The whole amount? Yeah.
What about money analogy?
Money analogies. Yeah, money works too, right? And actually, money is a very good way to think about fractions too. Because when you think about something like $1, it gets a little bit, this is where I think, you guys are actually really good at these. If you had $1, and I divided the dollar into 4 of them, 4 parts, what would each one of them be? Okay. Well, it'd be $1, but if there were 4, if I divided it into 4, well, there would be, each one of them would be 1/4 of a dollar. That's right. Each one of those would be 1/4 of a dollar. Now, what is 1/4 of a dollar?
4 quarters.
That's right. So what's a quarter?
25 cents.
So each one of these would be 25 cents, right? So as to what Taylor was saying, 25 cents then is equal to how much of a dollar? 25 cents is equal to how much of a dollar, Zoe? If you need 4 quarters to make $1, then 25 cents is how much of a dollar? How much of a dollar is 25 cents? Say it again? Well, it's 25 cents, but if you need 4 of them to make 1 whole, then what is it? Yeah. What do you think?
1/4.
That's right, 1/4. A quarter would be 1/4 of a dollar. Because you need 4 quarters. Does that make sense? So 25 cents would be 1/4 of a dollar, right? Now you can keep going. We can keep dividing that dollar up. How many pennies do you need to make $1? Challenge?
100.
You do. So, Nick, if I divided this dollar up to 100, I'm not going to actually draw it out. That would take forever. But if I divided it into 100, that would make the bottom part of our fraction 100, right? And I said, how much is 1 penny out of $1? It would be 1 cent, right? So what would it be in a fraction? What would it be in the fraction? If our dollar was cut up into 100 parts, it wouldn't be one whole. The whole dollar would be one whole. That would be this. Right? If we were talking about pennies, it'd be 100 out of 100. But what if I wrote this? And we're talking about pennies out of $1. Heston? I'm sorry to hear that. Do you need to go get some ice?
No.
You sure? Okay. So,
Now all I can think about is pizza.
we're talking about money now.
In my brain, I just see
Floating pizzas.
Pizza.
Okay, guys. If we're talking about pennies, and there are 100 pennies in $1, and I said the fraction was 1 out of 100, how much would I be talking about in terms of money? What would I be saying? I think Briggs just said it as he walked out. He had his hand up. Have a go.
1 out of 100.
1 out of 100, and what would it mean? What would I be saying? 1 what? One what?
R.
It'd be 1 part out of 100, but what was our 100? Yeah?
Our 100.
That's right. So then 1 out of 100 would be what? How many pennies?
1 penny out of 100.
That's right. So 1 out of 100 in this case would be 1 penny. 1 cent would equal 1 out of 100. Does that make sense? Now if you divided it up into how many dimes go into $1? How many dimes go into $1? Joel? 10. Right? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Right? So 10 dimes. So do the same thing here. 10 dimes. Now, what if I said, and now we're talking about 10 dimes, right? 10 dimes to make $1. And I put 1 out of 10. What would that mean in money? What would I be talking about there? Yeah?
1 dime out of 10 dimes.
That's right, 1 dime out of 10 dimes. So how many cents is that?
1 dime. 10 cents.
That's right. So this, in this case, would equal 10 cents, right? Okay, so we went a little off track, but yes, you can use money. It does get a little bit more complicated than shapes or food, right? But it does work. Are you asking to go to the bathroom? As soon as Bruce comes back. So, question.
Whenever you see like $6.99, isn't it actually just $7?
No, it's $6.99.
I would just pay $7.
Yeah, but then they'll give you a penny back. But that's why most stores have that little penny container up at the front. Some people just put that last penny in there, or some people are short 1 penny and then take a penny. So, and most people don't use a whole lot of pennies these days. So I've seen people pay in pennies and change. It's a lot. Okay, on this first line, which is 2/6, right? We're supposed to find 2/6. That means we've got 6 parts. Where do I put the 2/6? Where do I put it, Heston? What's your question?
If you had 5 pennies and it gave you $26, how much pennies would you have?
Well, what do you guys think? If it's 100 pennies per dollar, and you got $26 out of it, what's our math equation? What's our math equation, Andrew?
Like 2,060 pennies.
You're on the right path there. Because you wanted to know.
Because you have a 10 hundreds becomes
10 100s becomes 1,000, right?
2,000 plus a 6.
But it wouldn't be 60 pennies, would it? Wouldn't it be 600 pennies? Wouldn't it be 2,600 pennies?
I knew it!
Yeah, you were very close. 2,600 pennies. That would be a whole lot of pennies to be carrying around.
That's how much I have.
That's right.
That's how much I have.
You have $26 worth of pennies? That's a lot. You can go and get those changed into dollars.
That's what I did.
Good. Okay, guys, moving on. 2-6. Where do I put the 2-6? Brewer. Where do I put 2-6 on the top line? Right here? That's right. That's 2-6. Jack, where do I put 2/5? Right here? 2/5. You're right. Now, guys, which one is greater, 2/6 or 2/5?
2/5.
That's right, because it's closer to the whole, isn't it? It's not a lot closer, but it's still closer. So it is greater. Good. Okay, guys, do we have any questions on the math today? Any questions on math? Schmidt.
Okay, I'm the one that said 1/2. Because I know it's 1/4, but my brain got confused.
So you made a mistake. That's okay. But the problem was, not that you made a mistake, it was that other people listened to you and said it too. Never just go with what somebody else is saying. Make sure you know the answer when you call it out. It's okay to make mistakes, but you don't want to make other people's mistakes. You get what I'm saying? Learn from other people's mistakes and learn from your own. Now, I appreciate that that Chloe was willing to admit that she's the one who made the mistake. It's okay. It's no big deal. But nobody else should be following you.